Can somebody confirm you can hear me?
I can hear you.
Thank you.
Can hear you.
Thank you. My computer is going to be real slow because it's still processing the lecture file, so please bear with me. Let me close this down. I'll help a little. Let's put two here in here. All right, let's share my screen. Before we begin, are there any questions? All right, today is June 17th, and we should be discussing Lab 3, microscope basics. You've already began the infectious disease project, so please pick a topic and okay it with me. Everybody has to have a different topic, so that's why you need to check in with me. I also want to check in and see if I want to divide up your project, like I split influenza into influenza caused by influenza A, influenza B, influenza C, and HIV. I split into HIV-1 and HIV-2. Tuberculosis, I split into early stage tuberculosis and late stage tuberculosis. So there's a few I split. And usually it's with the ones that are very popular. Um, and I also want to make sure it's an infectious disease caused by one species. There's been one person who asked for a disease, which I told them they had to pick the species because there were many organisms or species that cause the disease she was requesting. And, I think she
Sorry,
took.
I'm a little late. I was out and my phone had died. I was finishing up some work.
Okay, we're just getting started. I'm talking about the infectious disease project. So if you've already picked the topic, then that's fine. If you haven't, you need to ask for a topic now because you guys have had at least 2 days to pick topics. You should request at least two topics in case the first topic you request has been taken by somebody else. Now, if you take an exotic disease or one that many people don't think of or care about or whatever, you should you can get one. But if it's a common disease like measles or polio or something like that, you should, which polio isn't common anymore, but you should probably pick two diseases in case your first is already taken. All right, so if there's no questions, let's begin Lab 03, Microscope Basics. Make sure I got the right worksheet there. You know, it looks like no, that's earlier. All right. Hmm, I'm not sure I have the right lecture. TM, what does TM stand for? All right, Lab 3, Microscope Basics. There is some reading to do for the lab. You should read the textbook, Chapter 3, through the end of the section on compound light microscopy before you begin this lab. There are some video clips and an online exercise for this lab. You're not physically going to be using a microscope. However, upon completion of this lab, you should be able to locate and name the parts of the compound light microscope along with describing their functions, be able to calculate the total magnification for each objective used, know the guidelines for focusing on a specimen with different objectives. You should know the names of the different objectives. There's the scanning objective, also called the 4x objective, the low power objective, or the 10x objective, the high power objective, or the 40x objective, and the oil immersion lens, or the 100x objective. Note if you use the name and not the power, you should note that the low power objective is not the lowest, and the high power objective is not the highest. And I don't use these names because these tend to get students confused all the time, the low power and the high power objectives. Estimate the size of a specimen when seen at different magnification powers, and you should be able to do that. We'll talk about how to do that in this lab. And then understand the rules for proper microscope care. You're not really going to be using a microscope, but you should know how to take care of a microscope because you've had microbiology. And then define the terms associated with the microscope. The terms are in this module and in our textbook. So you should memorize the names and the functions of these part of a compound light microscope. All of the microscopes, actually, that's not true. Most of the microscopes in the microbiology lab are compound light microscopes. We do have a few simple microscopes. The difference is a compound microscope has two lenses that magnify, and a simple microscope only has one lens that magnifies. Memorize the functions and the parts of these parts of the microscope. One is either the ocular lens or the eyepiece. Those two terms are used interchangeably. Two, that's the body of the microscope, or you can say the tube of the microscope. Three, that's the stage where you put the slide. Four is the stage clip. It holds the slide in place, and you can move this clip to move the specimen this way, or that way, or this way, or that way. I think 5 is probably the stage clip controls, but I'm not seeing 5. Oh, here we go. 5 is the stage clip controls, where you can move the slide or the stage clip this way and then that way, although this is already that way, and then this way by using these two knobs here. Where's 6? 6. I think 6 should be pointed to that dial up there. It's a little bit low. 6 is the iris diaphragm, which opens. Oh, good. The lecture file is finished, so my computer will start working faster. The iris diaphragm is a shutter on the microscope. It can open up to allow a lot of light in, or you can close it down to let less light in. You can actually close it down to nearly a pinprick. I don't know if you can see through that. But only allows a pinprick of light through. And that, like I said, should be there. That's the iris diaphragm. The red arrow is the, well, maybe I should look down here and see which one is which. It looks like the red arrow is the, oh gosh, what the heck is that called? Condenser lens. That simply puts a cone of light from the lamp up here onto the specimen. So 6 is the iris diaphragm. And like I said, that looks like it right there, actually. This looks like the lever for opening and closing the iris diaphragm. And then 7 got moved. Let me see if I can move that back. Nope. Anyway, 7, it should be right here, the red one. And, oh, there, I got it. No, I don't think I do. Yeah, for some reason it's not moving. Yeah, I can't move it. Anyway, 7 is the condenser lens. It should be here. If I take this off. Yeah, that took it off all right. Now I can't see it. 7 is the red one, and it's the condenser lens. 8 is the coarse focusing knob, the large one. That got moved a little bit too. There's 8 there. And 9, the fine focusing knob, the small knob. 10, the power switch. Right there, turning the lamp on and off. Some of our microscope have a power switch here. Others, it's in the rheostat 11, and you just turn the rheostat all the way off, and it turns the microscope lamp off. And then you just click it on, turn the rheostat on a little bit, and that turns the lamp on. And then you turn it further. What is that? Counterclockwise? And that turns the light on, or the rheostat higher. Now, apparently, they don't use the term rheostat in Australia, and the person who made this lab called number 11 the light intensity dial that controls how bright the light is coming from the illuminator, and rheostat is what it is, which is a light intensity dial, I guess. And then 12 is the illuminator or the lamp, shown here where the light comes from. So you should know all these parts of the microscope and what they do. Any question about any of those? All right. So you have a rotating nose piece to switch the objective in place. And there's the rotating nose piece. And you can see, barely, that looks like 1 over here, there's 1 there, and there's 3. And the 4th one is probably hidden right here. But there are 4 objective lenses, and they're right here on a rotating nose piece. And you can rotate this to bring the correct lens into place. You only see 3 here too. 1 here, that one, and there is behind that one. But there's 4. The name of the objective lenses, the 4x power called the scanning lens, the 10x power called the low power, the 40x power called the high power, the 100x power called the oil immersion lens. The total magnification on our microscopes of the 4x power, total magnification is 40x because the ocular lens is 10x. The total magnification of the 10x lens is 100x. The total magnification of the 40x is, of course, 400x. The depth of field is how much of the object you can see in your field of view when you're looking at the specimen under the microscope and you're looking at it at clearly. So with the 4x power, the depth of field is 4. When we see an object, I don't know if you guys can see this. Let me stop sharing the screen, then I can see it. Yeah, you can see it. You can see an object here. You're seeing the top, the middle, and the bottom, because we're seeing all of it. With the 4x lens, you have the deepest depth of field, and oftentimes you can see the entire specimen, meaning the top of the specimen, the bottom of the specimen. with the 4X lens. With the lower power ends, the depth of field is moderate. You can see maybe, let's use this one because it's a little bigger. You can maybe see half of the specimen in your depth of field. The rest of the specimen, if you can see it, it will not be in good focus. It'll be blurry if you can see it at all. With the 40X lens, it's even smaller, the depth of field. You can now only see from the very top down to about where I have the paper, a little bit of the specimen. For the 100X lens, you're really only seeing one plane through the specimen. So exactly where the paper is one plane. For at the very top, you're only seeing the very top. You're seeing nothing of the depth of the specimen. So the depth of field is very narrow with the 100X lens. The field of view is how much of the lens of how much of the slide you're able to see under the objective lens. With the 4X lens, you're seeing the largest field of view. And so of a slide, I don't know, something like this, you can see a large portion of the slide. Okay? With the 100X, the 10X objective lens, you're going to see a smaller portion of the slide, something like that. With the 40X lens, you're going to see a smaller portion of the slide, something like that. And with the 100X lens, you're going to even see a smaller portion of the slide. A little bit more than a pinprick. So some comments about the objective lens. The 4X lens is the easiest one to use. It has the deepest depth of field and the largest field of view. So if you can see the specimen, you're most likely to see it with the 4X lens. And then the 100X lens is the hardest one to use because it has the narrowest depth of field. To see it, you have to be focused exactly on it. And it has the smallest field of view, the smallest amount of the slide you can see under the lens. So it's the hardest to use. Any question about any of that? All right, remember the total magnification is the magnification of the objective lens times the magnification of the ocular lens. You should also note that when you see an image of an object under the microscope, the image is not only magnified, but it is also inverted and reversed. For example, there's the letter E that we can see with our eye. If we were to see it under the microscope, it would look like the letter E here. It is magnified, but it is also inverted and reversed. Any question about any of that? Oops, went too far. The iris diaphragm can be opened up or closed down to allow more light to come through and get on the specimen, or less light. But more importantly, the iris diaphragm affects the contrast of the specimen against its background. So if you need to improve the contrast between your specimen and the background of the slide, you can usually change the iris diaphragm, usually shutting it down to increase the contrast. So to get optimal Kohler illumination, and I'm not German, so I might be butchering that name. It might be Kohler, or it could be Kohler, or something like that. With the 4X lens being used, you should have the iris diaphragm open, almost open all the way. maybe not all the way. But actually for is it color illumination, you want the objective to give you a cone of light equal to the size of your field of view under the objective lens. And so with the low power lens, you have the iris diaphragm open, the highest, and then when you go up in power, you start shutting down the iris diaphragm to get optimal illumination and optimal contrast, which is called color illumination. And then when you go to the 40x, you even shut that iris diaphragm further. And with the 100x, you must shut the iris diaphragm down quite a bit further, down to close to a pinprick, or at least a very small amount. Because if you don't, you will not be able to see your specimen, at least see your specimen well. And that's just because the contrast of the specimen with the background of the slide will be so small that you can't see your specimen well. When you first use the microscope, you should always use the scanning objective, that's the 4x lens, in place. It's the easiest lens to work with, the easiest lens to find your specimen and begin focusing on it. So the 4x lens is the one you should use. You should also have the iris diaphragm fairly open with the 4x lens. Use the coarse focusing adjustment knob to bring the specimen into coarse focus. And that'll slowly raise or lower the stage and bring the specimen into macroscopic focus, meaning coarse focus. Then you use the fine focus knob to bring the specimen into perfectly adjusted focus. Once you've done this, never use the coarse focusing knob ever again unless you're using the 4x objective. If you're using any other objective, you should never be using the coarse focus knob. And the reason for that is our lenses are parafocal, meaning when you have the object under focus with one lens, hopefully you're seeing these two pens here, and then you move another lens, get this one out of place, move the other lens to see the specimen should be in coarse focus. So our lenses are parafocal, meaning the image should be in focus with all the lenses once it's in focus with one of the lenses. You may need to use the fine focus to bring it into fine focus, but you should not use the coarse focusing because it should be already focused. If you do make a mistake and use the coarse focusing knob at a higher objective lens, some lens higher than the 4x lens, and then you notice that the specimen is not something you can easily see, what you should do is start all over with the 4x lens and go through the procedure using the coarse objective lens to bring the specimen in focus once again. All right. So all additional focusing should be done only with the fine focus lens. Before changing to the next higher powered objective, what you should do is recenter the specimen in your field of view. For example, if this is your field of view and you're looking at something way up here, when you change to the next higher power objective, the amount of the lens that you can see under the objective lens will be smaller, something like that. And now our specimen will be out of the field of view. So before you switch the objective lens to the next higher objective, always bring the specimen that you're viewing into the center of your field of view. If you need to find focus, and then switch to the next higher power objective lens. The specimen should be near the center of the field of view, and it should be in focus. You may need to find focus, but you should not need to coarse focus. And you always do that whenever you switch to the next higher powered lens. You always move your specimen to the center of your field of view. And then you repeat step 9 whenever you switch from one objective to the next higher objective lens. From going to the 40x lens to the 100x lens, there's a special step, and that is you need to add oil. Oil has the same refractive index as glass, allowing more light to be gathered by the objective lens, and this greatly increases the resolution or the clarity of the image. So what you do is, let me stop sharing and then I can see. When you're, let's say, at the 40x objective lens, let's make that the pen here, the white pen, and you want to move to the 100x lens, let's pretend this is oil. What you do is you don't move the 40x lens out of place and move the 100x lens into place. What you do is you move the 40x lens halfway out of place and the 100x lens halfway into place. That will allow you to get your drop of oil on the specimen. Only add one drop and then move the specimen into the drop of oil. So let me put this like that. We're going to pretend this is the drop of oil. This hand being the slide. Yep. Something like that. So then you add the drop of oil, and then you move the 100x lens into the drop of oil. That 100x lens should not be touching the slide, and it should be touching the drop of oil, meaning the 100x lens should be close enough to the slide that when you add the drop of oil, then when you move the, maybe I can show it like this. When you move the 100x lens over the specimen, it'll actually go in the drop of oil, which hopefully you're seeing it like that now. Any question about any of that? Share my screen again. Whenever you use oil, well, let me talk about oil has the frame refractive index of glass, allowing more light to be gathered by the lens, greatly increasing the resolution and the clarity of the image. Oil should only be used with the 100x objective lens, and you have to use oil with the 100x objective lens, or that lens does not give you any better magnification than the 40x objective lens. And there's no reason to use the 100x lens without oil because the 40x lens is easier to use. It has a greater depth of field. It has a larger field of view. So it's easier to use than the 100x lens. And if you want to use 100x lens, you have to add oil. And once you add oil, you must clean the oil from the objective lens using lens paper. You should also clean the oil from the slide. You may use any paper, including lens paper, to clean the oil from the slide. You only use lens paper on the lenses, the glass lenses, because regular paper has wood fibers in them, and wood fibers can scratch the lens. If you scratch the lens, you'll damage it. You'll make the focusing of the specimen blurry with the scratched lens. The lenses are the most expensive part of the microscope, and so only use lens paper on the lenses to clean them. On the slide, like I said, those are relatively cheap. I don't care what you clean them with. You can use paper towels. You can use lens paper. Any question about any of that? And yeah, the slide will eventually become scratched. But like I said, to replace them is cheap. To replace the lens of a microscope is expensive. Whenever you use oil, remember you have to remove it with lens paper from the 100x lens. You should also check the 40x lens to see if it picked up oil. Because if you move your lenses over the drop of oil, I mentioned the 100x lens, let's go like that. The 100x lens goes through that drop of oil. Well, guess what? The 40x lens is close enough to the slide that it will also go through the drop of oil. And so you should always check the 40x lens to see if you accidentally got oil on it, if you're using oil with the microscope. And then there must be oil on the 100x lens if you use oil. So you have to clean it. Any questions about oil? All right. So the activities in activity 1, we're going to estimate the size of the field of view. Field of view is abbreviated FOV. Online students will not perform this activity with a microscope. Normally in the lab, we have you actually measure the field of view. We give you a ruler having millimeters, which is almost all English rulers have millimeters on one side, and then English units on the other side. And you measure the millimeters of the field of view of each objective lens. Therefore, the table below has been filled in for you because this class is online. However, you will be expected to know the information contained in the table and how to use that information or the formula below it. I guess that's formula above it. So you can use this formula above it to determine the size of the field of view, but it's just easier to remember the table, at least in my mind. For the 4x objective, the diameter of the field of view is 4.5 millimeters, meaning we can see 4.5 millimeters of the slide under the 4x lens, and that's 4,500 micrometers. With the 10x objective lens, the field of view is 1.8 millimeters or 1,800 micrometers. For the 40x lens, the diameter of the field of view is 0.45 millimeters or 450 micrometers. For the field of view of the 100x lens, the diameter of the field of view is 0.18 millimeters. And you can imagine the students have trouble measuring this because we only have a ruler which measures 1 millimeter, smallest, and they have to estimate the size of the field of view. And it actually is 0.18 millimeters or 180 micrometers in size. Any question about any of that? So, if we have a specimen that measures half of the field of view of the 10x lens, what is the size in millimeters or in micrometers of that specimen? So we have a specimen measuring half the field of view, so it's a fairly large specimen, and we're using the 10x lens, objective lens. So what is the size of that specimen? You're going to have to,
0.9 millimeters.
0.9 millimeters is correct. You will need to do that for the lab, by the way, this lab. Why is it important to know the diameter of the field of view for different objectives? Because it allows you to estimate the sizes of the specimen that you're observing. For observing prepared slides, online students will not perform this activity, but you will be doing a virtual exercise of this activity by completing the laboratory exercise at the end of this document. And you have to do that to answer the questions in the lab. We expect that you will know and understand the material in this exercise. So we obtain a prepared slide from the table, work through the tips for focusing, view the specimen with the scanning, the low power, let's say the 4x, the 10x, the 100x, excuse me, the 40x objective. And then to get the 100x, you need to move the 40x halfway out of place, add the drop of oil, and then move the 100x objective into the oil. All right. Activity 3, making a wet mount. Online students will not perform this activity and you will not be tested on this procedure. However, you should know how to make a wet mount if you do not know how to make a wet mount. A wet mount is just viewing a specimen alive in a liquid like pond water or in a drop of broth. And then you look at it under a slide. Usually you use a cover slip. You may put a small amount of, what is that called? Vaseline jelly in a circle. Put the specimen in a drop of water or drop of media in the circle of Vaseline jelly, and then put on a cover slip, and then look at it with the microscopes. So you should go through activity 3 if you haven't made a wet mount. Wet mounts are also important for microbiology because a wet mount allows you to see a viable cell in its natural environment, meaning its natural habitat. When you stain a cell, you're obviously looking at dead cells, or mostly dead cells, and they're not in their natural environment. All right, you should know about microscope storage protocol. Online students will not be handling real microscopes, but you're expected to know how to correctly store a microscope. When you're done with the microscope, you should lower the stage completely, remove the slide. If you used oil, you should wipe off oil from the 100x objective lens with lens paper, only lens paper, not chem wipe, not a paper towel. You should also check the 40x lens to make sure oil did not accidentally get on the 40x lens. Make sure the 4x objective is in place before you put the microscope away, meaning put the 4x lens over where the specimen used to be. Lower the light intensity knob to minimum. Turn off the light if you can. Unplug the microscope. Wrap the cord neatly around either the microscope or the cord wrapper. We don't do step number 7, at least in my class. And then always use both hands to hold the microscope. One hand holding the microscope and one hand supporting the base of the microscope. Keep the microscope in an upright position and place the microscope back in the same cupboard you got it from, the same way you got the microscope. Meaning if this is the back of the microscope and this is the front of the microscope, you put the front in the cupboard where the ocular lenses are pointing backwards, are facing backwards. Any question about that? Okay, there's some terms for this lab. You should know them. Laboratory exercise. You can view the video clips on general microscope focusing. So view that. And then there's a video on using oil for the 100x objective lens. So putting oil on the specimen. You can practice your microscope skills by using a virtual microscope. You actually need to do this to answer some of the questions in the lab. Let me see if that's true. If it isn't, it means I gotta change the summer lab. It should be true. Yep, they're right there. Where were we? All right, and then we have a virtual microscope, which you have to work on in this lab. It may take some time to download, especially if you have a slow internet connection. I've got a fairly fast internet connection. You see, this is taking a little time. And there's the microscope, virtual microscope. There it is there. There's the slides. There's the lens paper. There's probably the oil. There's a guide, learning, explore. Let's just go ahead and begin exploring. The question mark tells you need to click here. There's a variety of slides and magnification to completely open the microscope. Let's take a look at the plant slides. Onion root tip. And there we're looking at the specimen. You'll note that it's blurry. That's because you need to coarse focus. Make sure we're in the 4x position. Coarse focus to get the specimen into coarse focus. And I would say about there is the best. And then fine focus to get it in fine focus. Something like there. Then move, we're going to look at something like right here. Move that into the center of the field of view or close to it. And then go up to power to the next higher objective lens. And that rotated here. Now we're there. You should not use the coarse focus. All you need to do is use the fine focus. Something like there. I'm not seeing what I want, so let me move around a little. Not seeing what I want. It might be I'm not under high enough power to see. I'm trying to look for a cell where I'm looking at chromosomes. That might be one there. So let's put that in the center of the field of view. And then go up to the 40x lens. Oh, there it is there. That works. And that's actually in fine focus too. So let's move that to the center of our field of view. So I want to look at that. Then go up to the 100x lens. And it says you need to add immersion oil. So there it is there. Just add a drop. Move the lens into place. And then now we need to fine focus. Change the light. It's better. I'm not seeing, oh, there it is. Well, no, that's not it. Let me go down. You need to use lens paper to clean the lens when you use oil. Oh, there's one there. For some reason, this is not centered because it should be centered. There it is there. Can't quite get in the center, but there's what I'm trying to look at there. And then you can finally focus to see the chromosomes. All right. that's it there. Let's go ahead and remove the slide. And we need to clean the lens. So it's telling you to use the lens paper. That's cleaning the lens with the lens paper. Put the slide away. And you're going to need to look at the animal slides. The spider leg, I believe. You'll need to do that for the questions in the in the lab. All right, any question about how to use the virtual microscope? Let me go back here. And then we have practice naming the parts of the microscope. If you want to practice that, you can open this. To begin this, be very careful. Don't download anything. Don't download anything. So what you want to do is only click this button here, and then this picture here. Let's go like that. This picture here. So to begin it, it's saying the arm. So use which one is the arm, and 10 is the arm, which is right here. If you get the correct answer, it'll be green. The high power objective, I'm going to get this wrong. And it goes bonk if it's wrong. If it's right, I was thinking that was the oil immersion lens, but maybe that's the oil lens. All right. If it's wrong and then you get the right answer, it'll be orange or yellow-orange. Power switch, let's get everything wrong. It's really right here. So let's go here, here, here. After 3 attempts, it'll be purple for the wrong answer. And then we do it and get it, and it's red because we did it 3 times the wrong answer. Let's see what happens when we do 4. Stage clips, they're right there. So let's do something else. Purple there, and we're going to go there. All right, so we go there, it's red. Course adjustment knob, that's the large one. I only see one knob. Oh, there's the small one. So there's the course adjustment knob. Fine adjustment knob. If you do it correct, first time it's always green. Anyways, that'll help you learn the pieces of the microscope if you want. But when you use this, just be careful you don't download something. All right, and then fill in the answers in the worksheet. So let's go to the worksheet. It also has the general focusing link and the using oil link and the link to the virtual microscope and the naming the parts of the microscope in the worksheet. 4A, when focusing a specimen, you should always start with which objective. So write in the objective there. When using low power, high power, and oil objectives, only which focusing knob, adjustment knob should be used. The fine focus or the coarse focus. 4C, the type of microscope used in the lab is what? And you note this is 2 names to it. So you can't just say the light microscope, you have to say another name. And 4D, you should carry the microscope by holding on to the what with one hand and supporting the what with another hand. 4E, the objectives are attached to this part of the microscope, which can be rotated to click different objective lenses into place. So what's this called? If a microscope had an ocular lens of 10x and a high power objective of 45x, what would be the microscope's total magnification? So give me that there. When the stage is moved left, the image viewed through the ocular moves in which direction? When the stage is moved forward, the image viewed through the ocular moves in which direction? For H, which objective lens provides the largest field of view, or FOV? Give that answer there. And for I, which objective lens has the smallest field of view? For J, of the methods for light adjustment, which is the most important on the microscope? The lab does have an answer, but I will agree that there are two methods which are both important for controlling how much light gets in the microscope. So as long as you have one of those two. 4K, how large is the field of view when using the high power objective lens? You need to give an answer in millimeters or in micrometers, right here. 4L, how many hairs are in the animal slide when viewing the spider leg under the 100x objective without moving the slide from side to side? 2. Suppose a typical bacterial cell is 2 micrometers in diameter. In the circle below, which represents the field of view, when viewed using the oil immersion objective, state how many cells can fit across the circle under the oil immersion lens. You need to show your calculations for full credit. So you can't just give an answer that you got from somebody else. You have to show how you got your answer. So a cell is 2 micrometers long. You need to tell me what the size of the field of view is. And then take that number and divide by 2 micrometers to tell me how many cells you have. Any question about any of that? All right. I'll be here until at least 8:30 or the last student logs off. If a student really wants, I'll stay until 9 o'clock. But lately, you guys have been logging off early, and that's fine. But if you have a question, make sure you ask it before the last student logs off. Because once the last student is logged off, I'm going to log off as well. Any questions? If not, go ahead and get started on the lab.